right, everybody, welcome back. It's time for another deep dive. And today's topic is one that's been fascinating people, like, forever.
Yeah,
We're talking about time travel,
absolutely.
and
One of my favorites.
we've got a ton of stuff to get through today.
Yeah,
Articles, research papers. You guys sent in some amazing notes.
lots of good stuff.
And we're going to try to,
I think we can cover it all.
we're going to try to unravel some of the mysteries of time together.
Okay.
Now,
Sounds good.
I know,
To do it.
I know what you're thinking, time travel.
Right.
Isn't that just like,
Science fiction.
yeah, all that sci-fi
Yeah.
stuff? Well, we see it in movies all the time.
That's what we're here to find out.
Yeah, exactly. We're going to separate fact from fiction.
Yeah.
See what the science actually says.
Exactly.
It's a really, really intriguing topic, isn't it? The idea that we might be able to, like, bend time to our will to visit the past or go to the future.
It just sparks the imagination and challenges how we think about, like, what reality even is.
Totally.
Yeah.
Now, while Hollywood loves to play with this stuff, what's really cool is that there's actual science
Oh, yeah.
behind some of these ideas.
Definitely.
It all starts with Einstein's theory of relativity.
You got it. That's where it all begins. Einstein's theories, especially general relativity, I mean, it totally changed how we see time.
Right.
You know, it's not this like rigid, unchangeable thing we used to think it was.
Okay.
Time is flexible.
Okay, so
It can be warped, stretched, all because of gravity.
time is like a cosmic rubber band.
Yeah. Think of it that way.
It can be stretched and compressed.
You got it.
What does that even mean, like,
Eh.
practically?
Okay, picture this. An astronaut, right?
Yeah.
They're orbiting the Earth.
Mm-hmm.
Super high speed.
Okay.
Close to the speed of light. Now, for them, time actually slows down compared to somebody standing still here on Earth.
Whoa.
They would age slower,
Wow.
effectively taking a one-way trip to the future.
So you're saying time travel to the future is
It's theoretically possible.
possible.
Yes. It's called time dilation.
Okay.
And get this, we even have to factor this into tech we use every day,
Really?
like GPS satellites.
Ah.
They experience time a bit differently than us down here because of how fast they're going and their altitude.
Wow.
If we didn't adjust for these little time differences, GPS would be way off.
So even though we aren't, like, hopping into time machines,
Not yet.
the effects of relativity are, like, all around us.
They're there.
That's wild.
It's pretty amazing.
But Einstein's theories only take us so far.
Right.
To really dig into time travel, we got to look at things with even crazier gravity.
Yeah,
I'm talking black holes.
exactly.
Black holes.
Black holes, regions of space-time
Yeah.
where gravity is so strong, nothing, not even light can get out.
Intense.
And that gravity messes with time in wild ways.
Okay, so what kind of strange stuff happens to time around a black hole?
Imagine you're brave enough to go near one. The closer you get, the slower time would feel for you compared to someone watching from far away.
Whoa.
It's like extreme time dilation,
Okay.
like on steroids.
Wow. So black holes.
In theory, you could hang out near a black hole for a bit and come back, and like years, decades, even centuries could have passed on Earth.
Black holes could be like natural time machines to the future.
It's possible.
That's kind of scary, but also amazing.
Right.
But what about going to the past?
Yeah.
That's where things get really complicated, right?
Yeah, that's the tricky part.
Paradoxes and the grandfather
Yeah,
paradox.
exactly. Paradoxes are fascinating, and they really challenge our understanding of time travel. The grandfather paradox that you mentioned, it shows how you could have these causal loops where an effect is its own cause.
Yeah.
Like you go back in time and stop your grandparents from meeting.
Yeah.
Well, then you wouldn't be born, so you couldn't have gone back in the first place.
Right.
It's a mind-bending puzzle.
Makes you wonder if going back in time is even logically possible. Is it even possible?
Well, there are some theories out there trying to address these paradoxes,
Okay.
like the Novikov self-consistency principle.
Okay.
It suggests that the laws of physics would actually prevent you from doing anything that would change the past.
Yeah.
Another idea is the many worlds interpretation from quantum mechanics.
Okay.
It says every time travel event actually creates a whole new parallel timeline, so the original one stays protected from paradoxes.
So maybe time travel to the past wouldn't be as messy as we think.
It's possible.
Let's say we could actually travel through time.
Okay, hypothetically.
How would we do it?
Yeah.
Like, are we talking souped up DeLoreans or something even crazier?
Unfortunately, it's a bit more complex than just tricking out a car.
Right.
Wormholes, these theoretical tunnels through space-time,
Yeah.
those are one popular idea. They could connect different points in time And we could basically take a shortcut through reality.
Wormhole.
Exactly.
We talked about those with black holes earlier.
That's right.
But aren't those, like, just theoretical?
For now, they are. And
Yeah.
even if they're real, creating and stabilizing them would probably need exotic matter with negative energy density,
Yeah.
something we've never actually seen.
Right.
It's a big obstacle, but physicists like Kip Thorne have been looking into the idea of traversable wormholes.
So wormholes are still a maybe.
Yeah,
Any other theoretical ways to do time travel? Something maybe less,
less exotic.
less exotic matter dependent?
There are a few other ideas floating around. One is using cosmic strings.
Okay.
These super dense one-dimensional objects that warp space-time potentially enough to make these things called closed time-like curves.
Okay.
Basically loops in time that could allow backward time travel.
Closed time-like curves.
Yeah.
Sounds intense.
It's pretty mind-boggling.
But even if we figure out how to travel through time, there's still the question of should we?
Oh, absolutely.
The ethics are huge, right?
Huge ethical implication.
What are the consequences of messing with time?
Right. Could we change the past? Should we? Who gets to control that kind of power?
Right.
And how do we prevent unintended consequences?
Yeah.
Even small changes to the past could have ripple effects.
Yeah.
Big questions, no easy answers.
Almost like the biggest mystery of time travel isn't the how,
It's the why.
it's the why.
Exactly. Why would we do it? What are the benefits, the risks?
Wow.
It's a lot to consider.
This has been an amazing journey through the science,
Yeah.
the paradoxes, and the ethical dilemmas of time travel.
Yeah, it's a lot to unpack.
It seems like for now, time travel is still mostly theoretical,
It is.
but it's something that makes us think about the limits of our imagination, and it makes us face these really basic questions about our place in the universe.
It really does.
And who knows what the future holds.
Exactly.
Maybe one day time travel will be more than just this fascinating idea,
Yeah.
but even if it stays out of reach,
It's good to think about.
exploring it helps us appreciate how awesome and complicated time really is.
You got it.
So keep asking questions, keep exploring,
Yeah.
and who knows?
You never know.
Maybe you'll be the one to unlock the secrets of time travel.
Keep that curiosity alive.
That's all the time we have for today.
Thanks for listening.
See you next time.